Hi there, and welcome to this lesson on scatter diagrams and correlationship, one of my favorite topics. Now, in this lesson, I am not going to address linear regression. I will use another separate lesson to build on this example and then explore a little bit more of linear regression. On this lesson, I just wanted to really give you a notion of how to build a scatter diagram and also how to interpret it, as well as doing some basic calculation and understanding correlationships. Okay, so let me go ahead and take care of this title here, and let's get to it. So in this example, I have some hypothetical data here, and it's a small ice cream parallel in our local market center here. And what I'm looking at here is the change in temperature versus the monthly sales, the average monthly sales of ice cream. So does the temperature impact at all? Is there a correlationship between the temperature, the weather that we get, and the sales of ice cream? So what we're looking at here is what type of relationship do these variables have, and how strong is this relationship, and which way is it going? So hypothetical data, again, I have here some temperature measures randomly throughout the last 36 months, and then the monthly sales in Canadian dollars. So to build from scratch, to build a scatter diagram from scratch, what we're going to do is, first of all, as usual, select the data that we want to graph. So I'm just going to go ahead and select the two arrays. Now, when you're building a scatter diagram, it is important, Excel won't do it otherwise, it is important that you have two sets of data that are paired up in terms of the number of variables, in terms of the number of data points. So you need to have the same number of data points in order for this tool and other software to build that scatter diagram for you. So I have selected the data. Column B has temperature in Celsius, column C has monthly sales in Canadian dollars. I want to go to Insert, and to build this you do not need any special macro, you can do it straight in Excel. And I'm going to go to my graphs, my charts, and pick Scatter. Click there, right away you see the graph here. Now let's take care of the aesthetics and start interpreting what we see here. Okay, so the way that Excel print this out on the screen here for me is showing how my x-axis at the bottom, which is my temperature, which is also what we call in a scatter diagram study the independent variable or the predictor. So basically this is, we're studying if there's a relationship between the two variables, and later on we're going to see on a linear regression if there is any explanation on the variation that we see between the two variables. But for now I have on the x-axis the temperature and on the y-axis the sales. So first I'm just going to clean this up a little bit. You can learn as well here. I'm just going to get rid of the grid lines. I keep it clean. I like keeping very clean when I'm working with the scatter diagrams. Get rid of the grid lines here. This is personal preference, of course, you don't have to do it, but I like it that way. Also, let's give this chart a title. So let's say that this is the relationship between temperatures in Celsius and ice cream sales Canadian dollars. Okay, so now I have a title, and I'm going to just adjust this scale here a little bit. I'm going to get rid of the decimal places there, and also I'm gonna give this chart the axis legend. So I can go to my design, add a chart element, say primary vertical. That's gonna be my monthly sales, and then I'm going to go back there and add the primary horizontal, which is going to be temp Celsius. Okay, so again, just preference. I like it giving enough information so I'm not wondering, or the reader is not wondering what it is that I'm graphing. So what is this scatter diagram telling us? I put this table on the side here, and we're going to talk about it in a bit. I can see from this graph that as my x increases, as the temperature goes up, so does my monthly sales. So there is a direct, and in this case a positive, relationship between these two variables. I can see right here that if I try to fit a line within all of these data points, I'm going to do mechanically first. If I try to just simply draw a line there, just like by hand, it will look like something like this. So that's showing me that it is indeed a positive relationship, meaning as x increases, y increases. And this is, to the best that I can do here, my best fitted line. So what we can do is ask Excel to add that trend line for us. So you can click with the right button on top of any of the points, as long as you get all the data points, and you can go to add trend line. It is linear, and that's enough for now. So it almost looks like the one I did by hand, right? So I'm just going to change this line here a little bit, just to give it a little bit more emphasis. Shape outliner, weight, and then let's just, there. So I can tell that we have this type of relationship. The next thing that I want to do is to calculate the correlation coefficient. So that's what I have here in cell U2. Okay, it's a big formula, but of course Excel has a function to calculate that for us, and all you want to do is to say equal sign Correl, open brackets. You need to select the first array of data, which is in this case this one here, comma, and then select the second, and close brackets and hit enter. So this number can only go from -1 to +1. There's no other way you can get a number that doesn't sit between -1 and +1. If you do, you did the calculation wrong. And this is what's telling us in this table here. The closer that number is to +1, the stronger and positive correlationship exists between the two variables. The closest that number is to -1, the strongest and negative relationship exists between the two variables. If it's something kind of around at 0.5 or so, or between 0.5 and 1, it's kind of moderate. And then if you look at a 0 type of calculation here, there is no correlationship, or it's a very weak one. So what we got here is a 0.78, which sits quite up here. So it is moderate, almost walking to that strong zone, which implies there is no evidence for causation in this case, but there is an assumption here, a suggestion that these two variables go along, positively speaking, together. As my temperature increases, my monthly average sales of ice cream also increases. Let me show you another example that shows something a little different. This graph I already built just to save us some time. This is another type of analysis on the weekly workout hour. So say, for example, you're working out and you're watching your weight and you keep an eye on it. So I have here my workout hours on column B, and then in column C, weight in pounds in this example. And what you see here is the opposite of the first graph. And if you look at the correlation coefficient, it's a minus 0.53, which means that it's into that negative type of correlationship. What is that? Well, in this case, as my weekly workout hours increase, my weight decreases. Again, this is not a causation or a causality statement. It's simply implying that it makes sense. All other things remaining the same. That's a condition called ceteris paribus in statistical analysis. If all other things remain the same, my habits, the things that I eat, the things that I do, it looks like the more I work out, the more weight I'm losing. So that's the opposite of this first one that we did here, temperature in ice cream. And then you have sometimes a case of no relationship at all. So obviously the correlation coefficient in this case will be something really close to 0. And you see that your trend line is almost flat, right? It's flat. You don't see any trend. It's really hard to see where this is going. This is an example for a rainfall measurement, say the past 36 weeks, and pizza sales. So one thing has absolutely nothing to do with the other, and when you look into the variables, that's what we see on the graph. So that's it for now. Just a basic understanding of how to build a scatter diagram and also how to interpret correlation coefficient. For the fun of it, I would encourage you to check out this website here by Tyler Vegan, Spurious Correlations. He has all sorts of like completely nonsense, strong correlated things that if you think about, it just doesn't make any sense at all, but they are correlated. This is to make that point again that correlation is not causation. Correlation does not equal causation. So check out this website, tylervegan.com, Spurious Correlations, and you will see lots of fun and completely nonsensical examples of how we can actually see correlation between two variables, but at the end of the day, that correlation just doesn't exist. That's it for now. Thanks for checking this video out. I hope you've learned something here, and I hope to see you next time.